Lesson 9-5, using the distributive property. We can use the distributive property to multiply a polynomial by a monomial. We've done some practice with that already. So if you look at the picture here, I'm just distributing the A in both of them. First one, you have positive, and then just pay close attention to the signs. So this one, everything's going to be positive. Here, the C is negative, so your second term is going to be negative. Here, you're distributing a negative number, so both numbers, or both terms are going to be negative. And here, distributing a negative, but one of them will be a positive, and the other one will be negative. So when you distribute, just multiply each term by every term on the inside of the parentheses. You can also use the distributive property to factor a polynomial. Factoring is the process of expressing a polynomial as a product of monomials and polynomials. Think of factoring as the opposite of the distributive property. So here, if I have 6y squared plus 15y, I can factor that out. They both have 3y in common. If you factor that out, you're left with 3y times 2y plus 5. And then if you were to distribute that back in there, you would still get to 6y squared plus 15y. What we want to do here is undo the terms by undoing the distribution. So we're going to factor this polynomial. So I think for the greatest common factor, what does 12 and 16 have in common? The biggest number you can divide out of both of them would be a 4. They both have an a, so that means I can divide an a out. I can't do more than one a because 16a only has one. If I divide everything for a out of it, I would end up 12 divided by 4 is 3a squared divided by a. Remember, when you divide like bases, you subtract the exponents. That would be a plus 16 divided by 4 is 4. A divided by a is 1. So my answer would be 4a times 3a plus 4. If I were to distribute that, I would get back what I originally started with. This next one, I have 3 terms here. I look at 20, 45, and 35. The biggest number I can factor out of all of those would be a 5. All 3 of them have x's, and the most x's I can take out of all of them is an x squared. The last term does not have a y, so I cannot divide a y out. So if I divide everything by 5x squared, 20 divided by 5 is 4. The x squares divide out, and I'm left with a y squared. Minus 45 divided by 5 is 9. The x squared divides out, and I'm left with a y. 35 divided by 5 is a 7. It'd be a minus 7, because negative 35 divided by 5. And then the x squares divide out, and I'm left with my problem that I would use the distributive property to solve. Next, 49 and 21, the greatest common factor of both of them would be 7, and I can take 2 x's out. If I divide by 7x squared, I'm now left with 7x minus 3. And just to verify, if you want to distribute to see if that's what you started with, you may do that. Letter B, looking at 15, negative 6, and 12. Biggest number I can take out of all 3 is 3. All of them have a G. All of them have an H. The most H's and G's I can take out is just 1. So if I divide everything by 3GH, 15 divided by 3 is 5. G squared divided by G is G. H divided by H, then divide out. Minus 6 divided by 3 is 2. G's divide out. I can take one H away. So that gives me HY. And then plus the G's and the H's cancel off. 12 divided by 3 is 4. So my final answer in polynomial GH times 5G minus 2HY plus 4. x factor each of these. So I can take out a 3. Actually, no, I can take out 11 on this one, and I can take 2 n's out. If I divide 33 and 11, I get 3. N cubed divided by n squared is n, minus 121 divided by 11 is 11. I already have my n squared, so here's my final answer. Next one, 14, 6, and 10. The biggest number I can divide out of all those is 2. I see an A in all of them. I see a C in all of them. Divide everything by 2AC. C's divide outs. 14 divided by 2 is 7. A squared divided by A is A. And then I have a B squared left. Minus 6 divided by 2 is 3. A's divide out. C squared minus C squared divided by C is just C. Plus 10 divided by 2 is 5. AC's divide out. So I'm left with this as my answer. Example 2, we're using a word problem now. 1980 eruption of Washington's Mount St. Helens had an initial blast with a velocity of 440 feet per second. The expression 440t minus 16t squared models the height of a rock erupted from the volcano after t seconds. Factor the expression. So if I look at this, I think of 440 and 16. I can't take 16 out, but 440 divided by 8, I could take an 8 out of all those. So if I have 440t minus 16t squared, I can take a 8 out. I can also take a t out. And if I divide everything by 8t, I'm left with 55 minus 2t. And this would be our factored expression. Next, the rectangle has an area of 18x squared plus 36x. Factor the polynomial to find an expression that represents the area of the rectangle as a product of its length and width. So 18x squared plus 36x. I know that I can divide an 18 out of both and an x out of both. That leaves me with x plus 2. Because half of 36 is 18. So my length and width would be 18x and x plus 2. Another one, a golfer hits a ball with a velocity of 112 feet per second. The expression 112t minus 16t squared represents the height of the golf ball after t seconds. Factor of the expression. 112t minus 16t squared. If I think of 112, I can divide 112 and 16, and I get 16t. I can factor out t, and that leaves me with 112 divided by 16 is 7 minus t. Second part of our lesson is factor by grouping. So here you use grouping when you have more than 3 terms. And you're going to group them in two binomial groups. On this one, they're going to rearrange it. You don't have to rearrange it, but it does make it easier if you rearrange. So you're basically having two binomials. You're factoring each binomial, and then when you factor it out, you should have one set of parentheses that are the same. That forms one answer. Everything on the outside forms the other binomial for your answer. Let's take a look at an example here. 2uv plus 6u plus 5v plus 15. I'm going to group these two and group these two. And if I factor out 2uv and 6u, I can factor out 2u. That leaves me with v plus 3. On this side, I can take out a 5, a positive 5. That leaves me with v plus 3. You notice that my parentheses are the same, so that's in my answer. And what I have left on the outside forms my other binomial. of 2u plus 5. Next, factor this one by grouping. So I can take out x squared. That leaves me with x plus 7. And over here, I can factor out a positive 2, and that leaves me with x plus 7. So my answer, I have x plus 7, and I have x squared plus 2. Another one here, I can factor by grouping. I can factor out a t here, and that leaves me with w minus 10. On this side, I can factor out a negative 2, and that leaves me with w plus 10. The first one should be w plus 10. What I have left is t minus 2 times w plus 10. And if I were to FOIL that, I would get back what I had started with. Example 4, factor by grouping with the additive inverse. So what do they mean by the additive inverse? It is helpful to be able to recognize when binomials are additive inverses of each other. For example, 5 minus x is equal to a negative 1 times x minus 5. So this is just another way of saying you're going to factor out a negative number. So here, if I group this, I'm going to group these two and then group these two. And then I'm going to switch. Actually, before I do this, I'm going to switch it because this one has a p and this one has a p. I want my p's to be first. So I'm going to rewrite this as negative 3mp plus 21m as one of them. And then I have 4p minus 28. Now I can factor, and I can factor out a negative 3m here, and that leaves me with p minus 7. And on this side, I can factor out a positive 4, and that leaves me with p minus 7. So my answer would be p minus 7 times a negative 3m plus 4. Next, I'm going to factor these two and these two. If I factor out a negative 2y squared, that leaves me with y minus 3. Over here, I can factor out a positive 5. That leaves me with y minus 3. So my answer would be negative 2y squared plus 5 times y minus 3. And our final question, factor this one. So by grouping, I can factor out a negative 3x squared. That leaves me with x minus 11. Over here, I can factor out a positive 4. And that gives me x minus 11. So my answer, negative 3 times x squared, or 3x squared plus 4 times x minus 11. So that is our lesson on using the distributive property to factor.